Web development has changed. We are no longer designing digital systems solely for human eyes scrolling through visual layouts on a screen. Today, the primary consumer of your data is an AI agent. In a traditional web server, data processing is bundled with static HTML presentation. A user requests a page, the server fetches data, wraps it in visual formatting, and ships it out. This traps the raw information, making it difficult for automated systems and cognitive engines to extract and use. Take our test platform, PeopleChooser. It is a functional utility designed for dogs, allowing them to programmatically browse, vet, and select their humans based on real-time neighborhood metrics. To make an application like this work, we have to build it using a service-oriented architecture. This means treating structured, machine-readable data utility as the core product, rather than a visual web page. We solve this by splitting the system into two pieces. We separate the visual user interface from the logic engine running on the server, connecting them only through a standardized data pipeline. If a software platform cannot cleanly expose its intelligence via predictable, optimized endpoints, it becomes invisible to the surrounding machine ecosystem. The data request lifecycle starts at the physical edge, in this case, when a dog spots a human approaching at the local park. The dog doesn't need a web browser. They run a native, local client directly on their smart collar hardware. We built this local client using Go because it compiles to a single dependency-free binary, ideal for low-power edge devices. The moment proximity is registered, the caller constructs an HTTP GET request, packaging coordinates and a specific API key. That request travels to the cloud network layer, where it immediately hits our security perimeter. This functions like a corporate firewall. In a zero-trust ecosystem, applications don't get passwords. They use cryptographic OAuth tokens. Exchange is only permitted if that token is verified. If an administrator alters the token or the key is invalid, the security gateway blocks the programmatic entry and throws a security exception. The door stays shut. Because services act as infrastructure for automated data, strict identity verification at the network perimeter is the absolute prerequisite for distributing intelligence to autonomous devices. Once the API key clears the security gate, the request moves into the centralized cloud service backend engine. The server's routing logic parses the incoming query parameters. It reads the target identifier, specifically looking for the string human_01. This triggers a search of the storage layer. The service extracts Peter's metrics, isolating precise data points, high treat frequency, and a fetch stamina of 9. Instead of burying these stats inside HTML formatting tags, our backend skips this step entirely. Instead, the service packages the output into pure JSON. This lightweight text format is machine-readable and travels across the network in milliseconds. Stripping away visual presentation to serve raw, structured data is what makes a backend a true microservice. The cloud service dispatches the JSON payload back down the wire to the original edge device. The local Go client on the caller catches the payload and parses the logic in a fraction of a millisecond. The incoming data triggers a physical hardware response. Recognizing a high-yield target, the caller illuminates its LED indicator and prompts the optimal eye contact sequence to secure a treat. This same Cloud Engine code supports more than smart collars. It feeds mobile apps, automated dog doors, and tracking systems. If the data were locked inside a standard web portal, each of these devices would fail. They cannot click buttons or navigate visual menus. They require raw data to trigger their local logic. By separating the intelligence from the interface, we create infrastructure that scales across the machine ecosystem, moving beyond the browser window to integrate directly into automated workflows.